And now moving on, our next speaker is Professor Calum Semple, who I think probably needs not much introduction, but Calum was very much involved with the response in the UK with the ISARIC consortium and also government advisory bodies. Right. Without further ado, Calum.
We've got the select creme de la creme left in the audience. They don't know what they're missing out on. Thank you very much. Petros, lovely to hear the first-hand account from Cyprus. I'm sorry that this might not be quite such a good news story that I'm going to be presenting. It is my personal view. It does not represent those of my funders or the government to which I offered some advice. I'm going to talk to you, it's a mishmash, it's going to switch between research and policy because the two were very much intertwined. And I want to be very clear that the British government and the devolved nations, in my opinion, benefited from excellent scientific advice. That's not just because I was one of them giving it, but because it assembled a group of experts that gave their time freely and without prejudice. So the advice was certainly there. Anyway, to start with, the problem of trying to do research during a pandemic. The experience in 2009 with the influenza swine flu pandemic was that there was not a single clinical trial conducted outside of China. Not in Europe, not in the UK, not in the NHS. Some observational public health research got off the ground quite late. Clinical research, which was sampling and, if you like, laboratory-based, did occur in the second wave, but there were no clinical trials. And this is because it's difficult to do research. There's several loops in the process where you have to apply for funding, where you have to write a protocol, you have to go back to ethics, you have to wait for contracts. And all these things work against action research, if you call action research, research in time to make a difference. And out of that frustration, a group of us set up the International Severe Acute Respiratory Infection Consortium called ISARIC. ISARIC happens to be Aramaic for brotherhood. I think, although it's misogynistic, it does give an attitude that these are a group of intensive care doctors, physicians, public health officials, and scientists who wanted to lay down their swords and shields and work together collaboratively in order to prepare for the next pandemic. Set up by Jeremy Farrar, currently led by Sir Peter Horby. And the concept of operations was that existing research networks doing jolly good work in their own area would, in time of a pandemic, stop doing that research and focus their efforts on the pandemic research. So you might be a neglected tropical disease network working in Africa. You might be a intensive care research network working in the UK, but you would stop what you were doing and focus on the pandemic. We wrote protocols that were globally harmonized. We wrote case report forms that were globally harmonized. And we took these to the World Health Organization Ethics Committee and got them approved. We then took the protocols and case report forms to our regional areas and our country areas and had them approved there. So that meant that in 2013, with the risk of, and then again in 2015, with the risk of highly pathogenic avian influenza, these protocols were gaining attention and traction from some public health officials, including Dame Sally Davis, who was the Chief Medical Officer in England. And she instructed every NHS trust in the UK to approve the existing ISARIC protocols within 48 hours. If they hadn't responded within 48 hours, they got a personal phone call to their Chief Executive Officer asking them why not. And this was very effective. So the UK had in place since 2013 and refreshed in 2015 a pandemic research protocol that did basic clinical characterization. That's the who, what, and why of a pandemic. Now, if you were to sit down in front of an AI chat machine and give the following instructions, produce an image of a public health expert informing a government minister about public health activities, the Prime Minister looks befuddled, the public health expert looks angry, then I would say that this is the image that the AI might generate. This is not AI. This meeting happened to coincide with Boris Johnson's one-year anniversary as Prime Minister, and because of that, the Downing Street photographer shadowed his every move for 24 hours and captured this image of Chris Whitty, and you can actually zoom in on the paperwork on the desk if you're that inclined. And you'll see that it's the data about what was happening in other parts of the world and what was predicted to be happening. And on the 28th of February, the clinical study that I lead with Kenny Bailey from Edinburgh recruited the first 2 patients that had come in from China who had COVID and were admitted first to Hull and then later to Newcastle Royal Infirmary. And a picture paints 1,000 words, but just look at the face of Matt Hancock. That's really quite illuminating. So what's the Scientific Advisory Group for Emergencies? That's SAGE. By pure fluke, it turns out that when I made this slide quite some time ago, I've actually captured both government chief scientific advisors because Dame Angela McLean has now taken over from Patrick Vallance. These 3 individuals, that's Patrick Vallance, Chris Whitty, and Angela now, work as filters between a group of experts who are brought together to advise on emergencies, and they then condense that expertise and feed it as evidence to policymakers. The Scientific Advisory Group of experts do not sit round the table saying, wouldn't it be a good idea if we did this? Instead, we are asked to answer exam questions that come from policymakers. Now that could be said to be a weakness in the system. The other weakness in the system is that advisors advise and ministers decide. That's quite right from policy position. But as Shadid Javid said, and he was a great admirer, he changed that quote. He said, advisors advise, ministers decide, but ministers decide on their advisors. So you get the advice that you ask for. I can see that's raising some eyebrows. And that perhaps explains why our policymakers at one point during the pandemic invited in several experts from the fringe of opinion of British science and provided counterpoints to what the SAGE was providing. And that's what led to the Great Barrington debate issues in number 10 and quite a lot of pushback and some confusion about herd immunity and let it rip. So ministers do have to take responsibility for making decisions. Scientists can only restrict themselves to providing advice. SAGE is not a one-off. This was the first SAGE that you got to hear about, really. Previous SAGEs have been held in strict confidence. Going top left to right, we've got swine flu in 2009, the Eyjafjallajökull eruption, the tsunami that hit the Japanese power station, floods in the UK, the Ebola outbreak in 2014, earthquake, and I think it was an earthquake in Haiti, the Zika outbreak, another Ebola outbreak, a dam that was threatening to burst in Yorkshire, which seems a bit esoteric, but if it had burst, it would have flooded Media Centre in Salford, probably, because that's where the floodwater was going to go and hit Manchester and Salford. It would have killed a lot of people. So there's been a lot of SAGEs. SAGE comprises the government chief scientific advisors, of which there are several, governments, devolved nations, CMOs, observers, cabinet office, and then a small group of special advisors, of which there's between 5 and 12. SAGE counts round about 140 people, but of that there's only 5 to 12 that are external topic experts in one particular area. Remember, the government's got plenty of its own scientific advisors, so it doesn't really need SAGE most of the time. It's just when it's got something special going on, like a volcano, that it will bring in some meteorologists and some aircraft engineers because it wants to understand what's the effect of wet weather, volcanic ash, and what does it do to an aircraft engine. And if you've got that kind of scenario, that's when you need a meteorologist, a volcanologist, and someone that knows about aircraft engines. The rest of the time, government's quite good at getting on with stuff. The agenda for SAGE starts with a situational report, which I became part of for reasons that will become clear shortly. And then it's followed by forecasts from a modelling group, reports from subgroups, then papers can be commissioned. So if there's a question that's arisen, which we think we need scientific evidence to answer, we can commission that activity. That might come with money, or it might just mean tapping the shoulder of a friendly academic at another university and saying, we don't know the answer to this, can you do something about it by Monday next week? All of our papers were published. Multiple subgroups fed into SAGE, too many to mention here, but NerveTag is a standing committee which Julian and I were on and have been for some time, but others were set up specially to address issues such as the ethnicity subgroup, because it was found that certain ethnic groups were at vastly increased risk of severe disease. SAGE met 105 times, sometimes twice weekly, from January to February of the 2020 to 2022. That's the first, one of the first meetings I was part of. You can see we're all looking rather gloomy. It's all looking rather sad. And we started off using Zoom, and that's the last meeting. We're all happy and smiley because, of course, COVID was over. Not, but we were being stood down. So the problem, going back to the start of the outbreak, was that we did not understand how COVID was going to affect the population in the UK. We understood how it was affecting the population in China, although we didn't know enough about person-to-person transmission. Also, the Chinese had chosen to use a case definition that included contact or association with the wet food market. And consequently, as you got secondary and tertiary contacts that had no association with the wet food market, their case numbers appeared to drop. So I'll say that again. Chinese case numbers appeared to be dropping in January and February, not rising, because the data collection system was predicated on contact and physical presence with the wet food market. But those of us that were spotting cases in Thailand and Taiwan and other parts of Hong Kong knew that this was spreading and that a pandemic was on the way. The ISARIC protocol was activated and was very successful. It used paper and pencil. It did not use technology. It did not use AI. And that's the actual SAGE report that I gave on the 26th of March. We were commissioned to produce a report based on 1,000 cases in total. In fact, our very first report had 800 cases in it. And we could show the bottom right-hand side shows the demograph with a count of cases and the deaths in red. In the middle, we could show use of resources in the hospital. So we could show how many ventilators were being used, how many patients required high-flow oxygen, how many patients went straight to intensive care or needed intensive care later on. So this was incredibly useful for planning the resources that the UK was going to need. And if that was what was happening with the first 1,000 cases, what we're going to do with the next 100,000 cases. So this is vital information. The other thing that we did with that first report was confirmed that the community case report, the community definition of COVID, which is cough, fever, and shortness of breath, was good enough. It was finding about 95% of cases. We didn't want to add in other things at that moment because we weren't sure how change of smell was going to be valid or not. But if you have a case definition, I would say you should stick to it. You shouldn't keep changing your case definition throughout a pandemic, because that means you lose your baseline. And unfortunately, that was another mistake that we made in Britain, is that we changed our case definition. So what's going on here? There we are. So we produced that kind of report twice weekly, updating it every 30 minutes using the dynamic reports that are coming in from 360-odd hospitals throughout the United Kingdom. I'll draw your attention to the demograph on wave 2. The demograph starts at the bottom with children, so you see there's relatively few children affected. And as you get older, there's more severe outcomes, more hospitalizations, more deaths. And you'll see there's a bump in women of reproductive age. We assumed that was to do with increased use of maternity services, but in fact it turns out that these women were actually probably more susceptible through work exposures and possibly through pregnancy itself. And these reports and the raw line level data we shared openly. So the traditional method for academic research is that a great university of excellence will work closely with its local teaching hospital and behave like Calum from Lord of the Rings, holding its samples and its data close to it because it's precious, and they won't share and they'll write their paper secretly, and 6 months later they'll try and publish it. And what use is that to us in a pandemic? The ISARIC process was about collaboration and open access, and that was one of the reasons we were so successful. This is the demograph for wave 3. Can you see how it's totally changed? If I go back to wave 2, upside down, I've got a spinning top. Wave 3, what's changed is you got vaccination. Vaccination, which has been brought in, basically leveled the playing field of risk for severe disease. There were still some frail elderly were still dying, but in fact, the vaccine was working extremely well. So by the end of the 2 years, we'd collected clinical data from 303,000 patients. And at the same time, we got samples in. Now, the samples were essentially a different project, and Ken Bailey ended up taking responsibility for most of that. And I looked after the data, and Ken looked after the samples. The data would come from the hospitals, would come into Oxford. It would then get sent up to Edinburgh, where Ewan Harrison at the Usher Institute would do some amazing infographics and analysis. And so again, huge collaboration there between Liverpool, Oxford, and Edinburgh. But the samples, that was another issue. What we did with the samples was, rather than having each teaching hospital and each university hold on to 20 samples, which means you can't do a powered study, we got all the samples in England sent to Liverpool, and all the samples in Scotland and Ireland sent to Glasgow. And we then aliquoted them and sent them out. So within about a month, we'd sent out 200 samples to the Jenner team in Oxford to help them validate the vaccine, and to Public Health England to validate the tests, which meant that the UK was ahead of the rest of Europe in validating tests and getting the vaccine going. We didn't hold on to the samples in Liverpool. I came under a lot of pressure to shift samples into Liverpool research projects, but that would have been a breach of trust. So the next 200 we sent to 20 research institutes, including Liverpool and all the other places as well. So the first 200 all went to public health activities. The next 200 samples went to the top 20 institutes. And after that, we shifted around about 35,000 samples to research institutes throughout the United Kingdom and to pharmaceutical companies to work on. But by doing this process, we greatly accelerated research in the United Kingdom. So it's not just me saying this. This is a picture of Chris Whitty using the demograph from wave 2 that I showed you, and him explaining why the vaccines was getting rolled out to the elderly first. And he was using our data to do that to the nation. We were the only source of data for the first wave from hospitals. But by the time the second wave came, hospital episode summary statistics were starting to be digitized, but they just couldn't have the granularity that we could generate using our study. And we pre-printed everything, and we put most of our data went into government reports. Despite that, the top journals were still happy to publish our work as original research, and we managed to get 5 Nature papers out of that work. Now, you might say that we were too big to fail, but we've activated the ISARIC protocol several times since the end of COVID, and the most successful activation occurred in mid-2022, when there was an exceedance of non-EA hepatitis in children. Now, this is a devastating disease, which typically in the United Kingdom we'll see 5 or 10 cases a year of children that for no good reason develop acute severe hepatitis. Their transaminases elevate, their clotting fails, and they have fulminant liver failure requiring transplantation. This is tending to be a lethal illness. We were seeing something very similar, but a slightly different age group, a slightly younger age group. And in fact, we managed to get many of them into transplant, and we didn't lose any children from the United Kingdom. 1 child from Ireland did die. But using the ISARIC process, we were able to get their data and their clinical samples, bring them into 2 centres of excellence, UCL and Glasgow, where they were able to do metagenomic approaches to look for the viruses. Now, everybody assumed, because the first frontline virology was finding adenovirus, that this was an adenovirus-driven disease. And the other presumption was that on the background of a pandemic, this was something to do with coronavirus serology or vaccines or past exposure. But in fact, all the research showed that not to be the case at all. In fact, it was totally unrelated to coronavirus. And what the metagenomics people did was pulled out adeno-associated virus, which is a dependovirus, which becomes activated in the presence of small amounts of adenovirus or small amounts of human herpes virus 5 and human herpes virus 6. But once that adeno-associated virus becomes activated, against a background of a particular HLA type, you get a very profound inflammatory response in the liver, and the liver is turned to sludge. And what we can now say is this work was replicated by an American group, so 3 different groups have now confirmed that the cause of acute severe hepatitis in children, previously known as non-A to E hepatitis, is an interaction between adenovirus or HHV6 or HHV5 as the helper, and then the adeno-associated virus AAV2 against a background of HLA DRB10401, which is one of the old Viking genetic traits. And to me, that's quite a major discovery, that this is a disease that we've known about since the 1970s as virologists and never quite understood. And we got 2 Nature papers out of that. So as I wrap up, that was the state of play in 2009. And in 2020, because of the prior work that we did with ISARIC, we managed to get our observational public health research off the ground right from the start of the pandemic, at a time when our own public health agencies had been, for political reasons and for funding reasons, had lost direct access to hospital data. And so that was what we were doing. And then we also managed to get the samples into clinical research, which meant that we could get assay development and vaccine development kick-started in the UK. We also were able to provide some support for recovery and remap CAP and get the clinical trials off the ground in the UK as well. So we were quite pleased about that. We couldn't have done that without 2,648 medical students and nurses who collected the data the old-fashioned way with paper and case report forms. Perhaps in the future we'll have some fancy AI way of doing this. But that's basically how we used research to generate evidence to inform policy in the UK. I take no responsibility for the political decisions that arose from that, but thank you very much.
Thanks, Calum. That was really, really interesting. And a real bird's eye view as to what goes on in the machinations of government, etc. In the interest of time, we have the next session is at 3 o'clock, and it's hybrid, so we need to hit that. We're going to have questions for Calum then, if that's okay, or over coffee. We're going to have a quick coffee break now until 3 o'clock, but can everyone be back here sharp at 3 o'clock? Okay? Thank you very much.